Good morning, afternoon, or evening. How y'all doing? Welcome back to Mr. Moore's Algebra 2 class. Today we're just wrapping up 4.1, sorry, and we're just talking about ordered pairs and graphs. We talked about what ordered pairs were. They're the x comma y coordinate. It's a point on a graph. We talked about the coordinate plane, which is also known as the Cartesian plane. We talked about the x and y axis. We talked about plotting points, reading ordered pairs as well. And then we talked about just the simple act of making a table of values when you're given a function. So we know that the x is independent. That means that x can be anything it wants. The y is dependent. So when we're making a table of values, we literally plug in x values that are valid, okay, into the function, and we find all of the y values. Now, today I'm just going to talk to you about a real quick little word problem, an easy word problem, that uses the simple skill of creating a table to visually display data. Business uses algebra all the time. And I figured a nice little example would help bring the point home. You open up a small business repairing smartphone screens. It's pretty legitimate, right? That's a good business, okay? Your initial cost, because everything costs money, my brothers. Your initial cost of starting the business was $110,000. Let's think about what that means. That means that whether you repair one iPhone or smartphone screen, or you repair 42 billion, how much did you spend to start that business? 110,000. Whether you made money or not doesn't matter. You had to shell out $110,000 to start this business. Does that make sense? Okay. Now, and it also costs you $30 to repair any smartphone screen, because that may be the cost of the material to get the screen, right? Maybe the screws that it takes to put in the screen. I don't know how do you repair those, but whoever does repair them, let's say that is a cost for every screen they repair. Write an equation which relates your total cost to the number of screens you repair. Then plot the total cost repairing 1,000, 2,000, 3,000, 4,000 smartphone screens. Now, this can be daunting to a lot of people, but I'm hoping and praying that it's not daunting to you. I'm going to talk to you a lot about graphs today, so please make sure you ask questions, guys. Okay, so let me actually split this up, because to really do a good job here, I want to show you. Okay, first of all, we're going to write the function. You open up a small business repairing smartphone screens. Your initial cost of the starting the business is $110,000, and it costs you $30 to repair each smartphone. You know me, label, 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 label. I'm going to call X the number of smartphones repaired. That's my X. That's my independent variable. I can have a great start of the business, and I can have 30 people waiting outside my doors. I can have a very slow start, and I can have 0 people waiting outside my doors. In fact, unfortunately, sometimes businesses go out of business because not enough people show up. So the number of smartphones that I'm going to repair, that's X. Y, in this particular case, is going to be my total cost. Okay, this isn't what I'm earning. I haven't said how much I'm charging. This is not an earning. This is an expense. This is a cost. So now that I labeled my total cost Y equals $30 per phone that I repair X plus the $110,000 that I had to start with. That's my total cost equation. Does everyone understand how I extrapolated that information from the word problem to the equation? Yes, sir. Oh, does the Y equal total cost? Okay, if the Y is total cost, why would the Y be 110,000? You started the business with 110,000, and it costs you $30 to repair every smartphone. So your total cost Y is the $110,000 you had to shell out plus $30 for every single phone you repair. That's what it costs you. Okay, my brother? That's what it costs you. Does that make sense so far? Okay, now we're going to have to make a table because I want specific values. I want to plot the total cost of repairing 1,000, 2,000, 3,000, and 4,000 smartphones. In this particular case, we're not going to use the Moral 5. A couple of reasons we're not going to use the Moral 5. First of all, you can never use the Moral 5 for real objects, real life things. Can you repair -1 smartphones? No. You can repair 0 though, right? That would work. But when we're talking about real life situations, real world problems, negatives don't exist. You can't have negative money. You can't have negative bread. You can't buy negative jeans. Okay? You can lose money. You can have a negative profit. Okay? But you can't have real items that are negative. So I'm going to make a table. My X and my Y. My X in this case, they're telling me what to use. I want to find the Y when X is 1,000, when X is 2,000, when X is 3,000, and when X is 4,000. So what is my cost, my total cost of repairing 1,000 phones? Well, Y will equal 30 times 1,000 plus 110,000. 30 times 1,000 is 30,000. 30,000 plus 110,000. It's going to cost you a total of $140,000 if you repair 1,000 phones. This is how the cost structure is created. Once they figure out how much it's going to cost them, then they know how much to sell for. If it's 2,000, well, what's my Y when X is 2,000? Okay, yes, because we have Y equals 30 times 2,000 plus 110,000. So that's 60,000 plus 10,000 is 170,000. And when X is 3,000, we got Y equals 30 times 3,000. Thank you, my brother. Plus 110,000, which equals 90,000 plus 110,000, which is 200,000. And last but not least, when X is 4,000, what's the cost? What's my total cost? Yeah, you've got 130 times 4,000 is 100. No, not 200. 12,000. Sorry, right? No, not 12,000. 120,000. 120,000 plus 110 is $230,000. Does that make sense so far, guys? Are you sure? Okay. Now, how do you graph this? Okay. This is where the magic of knowing really how to make graphs comes into play. First of all, the X here is going by thousands, and the Y's here are in the hundreds of thousands, correct? We're not going to make intervals of 1, are we? That makes no sense. Now, what are my intervals going to be? This is where you have to use a little bit of logic. Yes, sir? Yeah, for sure. When you're doing the intervals, thank you, my brother. This is my x-axis, this is my y-axis. Label, especially with real-world problems. So X is the number of smartphones. So number of smartphones. And I'm going to go by thousands here for sure. 1,000, 2,000, 3,000, 4,000, etc., etc., etc. Now, with the Y's, guys, we're not going to go by 100,000 because it's too much of a jump. We're not going to go by 130,000. It's too much of a jump. You're going to have a lot of inaccuracy. I'm not going to go by 10,000s because I'm going to have a really large graph. Yes, sir. Yes, okay. Let me explain that. You're awesome. I love it. What I'm going to use is called a line break. Now, all of us have seen a line break. You may not have really understood it before. Well, that's why I'm going to teach it right now. A line break is this little symbol that goes like this. And the line break tells the reader, hey, dude or dudette, listen, I skipped a bunch of numbers before I started this graph, and I'm starting this graph at 140,000. Now, some of you may say, okay, how is this different than this? Well, the one in red, I'm going by intervals of 1,000. Okay? This guy here, I am not going by intervals of 1,000. I am telling the reader, hey, dude, I skipped values. Every mathematician knows this. Hey, I skipped values. I'm starting at 140,000. But those are not my intervals. Now I'm going to go by 10,000. 150,000, 160,000, 170, 180, 190, 200, 210, 220, 230. All of these are in, of course, hundred thousands. So this is just telling me, hey, dude or dudette, I skipped a bunch of values. I'm just starting at 140,000, but now I'm going by 10,000. Does everyone see this? Please ask questions now because this is going to really be important for you later. Yes? Okay, what he asked was, what if I wanted to go by 100,000s? First of all, that'd be a horrible interval. Because if I went by 100,000, then you went 100,000, 200,000, 300,000, and now you're going to have a lot of estimated points, aren't you? You're going to have a lot of guessing points. So the answer to your question, yes, you can do it this way, but that is not really too good. This is a much better, more accurate way. Because I'm showing the reader, hey, I skipped all of these values. I'm starting here, but my intervals are 10,000. Now I can graph this way easier. At 1,000, I got 140,000. So let's do this in black. Okay, so boom. 1,000 phones cost me 140,000. 2,000 phone repairs cost me 170,000. 3,000 phone repairs cost me 200,000. 4,000 phone repairs cost me 230,000. And this pattern is going to continue forever. Right? You with me here, guys? See what I'm saying? Promise. Yes, sir. Yes, if you were doing homework or on a test, yes, sir. No, on the real test, I want you to show all the values. I just did this because of time's sake, sir. But no, on a test or quiz or an SAT, you're going to have to actually do it unless you make a little key for yourself. Okay? If you make a little key for yourself and you tell me, hey, all of the Y values are in hundreds or in thousands, then that'd be okay. You have to definitely always display to the reader what it is they're seeing. Thank you, my brother. God bless you. Yes, sir. Does that make sense, boys? Okay, may I continue? Are you sure? You sure, guys? Everyone sure? Okay. Thank you, my brothers. Wait. Okay, now, as far as the graphs go, whoa, why is that so ugly? There we go. Now, let's talk about misleading graphs, guys. Now, the good news about this, there's not a lot of math involved in misleading graphs, but it's extremely important for you to understand how to read a graph and how to see how people can mislead you with their graphs. Okay? Let's say that you have a company that you want to invest in, okay? This is a peanut company, all right? And according to this table here, I am trying to, let's say, display the production to a potential investor. Okay? Which graph here looks much nicer? Well, you guys tell me which one looks more appealing to an investor. Hey, whoever said the first one, no, this doesn't look appealing to me at all. This looks like it's going down, and it looks like it's going down fast. Right? This one looks like it's going down, but not. Okay, sorry about that. So, like I said, guys, the one on the right looks like it's decreasing, but a lot less. Aren't the numbers exactly the same, though? Okay, whoever said no, yes, they are. Yes, they are. They are exactly the same. Now, what's the difference? Yes, sir. Yeah. This is the same data, except they use different values here. What did they do here? First of all, they did this incorrectly. They should have used a line break, right? But they started at 6,000, and then they went by hundreds. So this looks much more drastic. Over here, they went by intervals of 1,400. So they elongated my axis. They made things look bigger. These two graphs, if you were just to see them, you would say, oh, which company's doing better? You know, you would think that it's this company. This is a misleading graph. Graphs can be misleading based on the intervals. So you must be careful as to what they're trying to fool you with. Does that make sense? Okay. Next. Let's look at this, guys. You got preferred donuts. You got frequency, and you got the brand. So there's brand X and there's Joe's brand. Frequency means how many people buy it, okay? If I'm an investor here, which graph do you think I'm going to show the investor? Yes, sir, my brother. I would not show, oh, it depends, right? It depends. If, let's say you're an investor, right? But I got paid a little extra by Joe's to make it look prettier. Who would I have shown, what graph would I have shown you? The first one. This looks like Joe is just destroying brand X's sales, right? But really, they're not that far apart. They're only 5 apart. They're only 5 apart here as well. But in this case, they're going by 2s. In this case, they're going by 5s, but they started at 5s. Here they're going at 2, but what happened here? They had a line break. So whenever you have a line break, it tends to skew the results. The results are the same, but it's going to look different to either benefit or hurt you. It depends. Does this make sense? Okay. Okay. MediaMattersCom.com reported that CNN.com used a misleading graph to exaggerate the difference between the percentages of Democrats and Republicans who agreed with the Florida court's decision to remove the feeding tube from Terry Schiavo. There's a true story. Rest in peace, Miss Schiavo. God bless her. If you don't know about this, look it up on YouTube. They love to do this in the news. They love to show little graphs. And people that don't know how to read graphs would think what about the Republicans and the independents in graph 1? Not that they're losing, guys. Look at what this was. Look at this was. This was, they reported that a misleading graph exaggerated the difference between the percentages of Democrats and Republicans who agreed with the court's decision. Thank you. This first graph makes it look like the Democrats are the heroes of the universe. Makes them look like the Republicans and the independents didn't care one bit about this young lady. Doesn't it? What's the reality though, guys? They all cared. They all cared. Yeah, were there 8 more Democrats? Yeah, okay. But they all cared. They were all pretty much there. But you see this in the news. Oh my goodness. The Republicans and the independents are horrible humans. Guess what, guys? We're all humans. It doesn't matter what party affiliation you're in. Just by the way, be proud that we're Americans. Does this make sense, guys? See how powerful misleading graphs could be? Does that make sense? This is what they put up there during elections and stuff. These are real graphs. Both of these graphs are real and accurate. Except one is misleading. Again, why is the one on the left misleading? Again, they did that line break thing. Sir, my brother. Okay, that's a phenomenal question. The question was, it's legal to exaggerate things to the public. Well, let's be honest. Are either one of these graphs truly lying? No. The numbers are the same, so this is not illegal. I hate to say this, but that's why we get an education. Brothers and sisters out there watching it online. That's why we get an education. So we can learn how to read data, so we can learn how to not be misled. So with all due respect to everyone in the world, if you don't know how to read this, that's on you, not on the media. That's why we get educated, so that we won't allow anyone to pull the wool over our eyes. It's a brilliant question, though. Thank you so much. Does that make sense? Does that answer make sense, guys? No one's lying to you here. They just put it in a different display. Now, do you know how to interpret that? That's the question. Does that make sense, guys? That's pretty useful, right? And we understand the line break thing? Awesome. You guys rule. Thank you so much. I hope you learned a lot. God bless you and have a great day.